Hi everyone, and welcome to our first tutorial using Tinkercad. We are going to use Tinkercad to get introduced to Arduino and how Arduino works. Before we physically take Arduino boards and start wiring them, I'm going to make sure we understand how they work just so we don't damage the boards, know exactly how they're going to work when we physically start to use them. We're going to begin working with Arduino in a virtual world, and that's what we'll use Tinkercad for. When you open it up, you can see on the left hand side we can do things like 3D designs. We want to focus on building circuits, so you're going to click on circuits, and then in this menu here you could either create a new circuit or you could go and look at an existing circuit that you previously built. You can click on here and you've got different options. We can duplicate it, we can delete this. We're going to go up here and we're going to create a new circuit. So when I do that, I get this window here. This big space here is the palette. This is your working window where we can bring in different components and things like that. If I look in the upper left hand corner here, I've got some tools here. This is for rotating components. If I need to rotate them, I can delete components by using this here. I've got the undo and redo features here. So those features are in the upper right hand corner. On the right hand side here, I've got a drop down menu for choosing components. I've got basic components here like resistors, capacitors, potentiometers, and other components. There's even more here, but for now, I'm just going to use the basic components. We're actually going to scroll down to Arduino because if we click on this, it actually gives me a number of pre-built Arduino circuits that I can play with and modify and learn from different ones here. So I highly suggest you do that. Take the time to go through some of these circuits and try to understand what's happening with them. It will make it much easier when we actually pull out the physical boards and start working with them. The upper left is a Arduino board connected to a breadboard. So this is a really useful one to start with if you're starting from scratch. So I'm just going to click on this and just drag it over, and this is the view. So looks like this. If I use my scroll on my mouse, I'm just going to zoom out here. Here I've got the Arduino board and it is connected to a breadboard. The way that we power our circuits on the breadboard is not through a 9-volt battery, but we're going to begin by using the power supplied on the Arduino. If I zoom in here, you can see that this rail down at the bottom has a 5-volt out. So by connecting the USB to the Arduino board, we can actually get 5 volts out, and that can power a circuit on our breadboard. Doesn't supply a lot of power, but for certain circuits it's sufficient. Notice we've got a ground here. So that is the negative terminal of your battery, if you will. And if we zoom back out, that is connected to our breadboard, just like we did in Unit 1. Notice here that they used red wires, and notice they've fed them around here like this so that the wire's not covering anything on the UNO board. I'm going to make sure we're not covering up things. Try to make it so you can read all of these here, because these are very important, and these are very important down here. So notice they wired this around here to the negative terminal or the ground side of the board, and the positive power rail they've wired like this. They've used red wires for the positive power rail and black for the ground or negative terminal. Please follow that same notation when you're building. Wire colors are important. If we have enough wire colors, you should use the right ones. Notice that they've connected the positive power rails together with a wire here. They've connected the ground side power rails together here too. So that's always a good habit. So you can use the power rails and ground rails on both sides of this board. Now, if I want to build a simple circuit, I can do that by going to here and choose basic components. So if I grab a resistor, I'm going to bring it over here and I'm going to put it like this. And what pops up is the resistor. I can actually name it if I wish. And it defaults to a resistance of 1K ohm. You can change that if you want. We can change this. So this is 220 ohms. And notice it actually updates the right color code right on it. If I click on this here and I go over to here, right now, as you can see the way I've got this wired, I've actually shorted out the resistor, so I need to rotate it. So I'm going to rotate it here like so, and that way now the resistor is not shorted and it looks like that. Now if I want to power an LED, I'm going to need a resistor and I am going to need a LED in series with it. When I drop it in, it shows me again that I can name this and I can actually change the color if I wish. Now, we're going to learn more about the inputs and outputs on this board here. But for now, we're going to choose this port 13. And when I click on it and I drag a wire over to here, what I've done is I put a connection from port 13 on the Arduino UNO and I've connected to this side of the resistor. The current will flow. If this sends out a current, it will flow through here through the resistor. Notice this little angle here, that shows you that that is the long leg on the LED. That is the anode, and you can see that even pops up here. So this is wired properly if this is the positive power source. Now any circuit has to be completed, so I need to wire this circuit back to ground. So I'm going to click on this here and I'm going to draw a wire to the negative power terminal, and let's make that black like so. And in fact, let's go here, and just because that is powering this circuit, let's make it red like so. So there. Now what I've done is I have connected port 13 to a resistor diode circuit. And what I'm hoping to do is turn this on. And in fact, what I want to do is turn it off and on a certain number of times. The way we do that is with code. So the Arduino is very powerful in that we can build hardware circuits, and then we can do different things with those circuits using software. What you do is you go up here and you click on code, and it gives you a menu of things that we can use. We've got output signals here, we've got input signals, we've got control signals. You can go through these and get a feel for how these work. We're going to build a really simple circuit here. I'm going to first just take this here and I'm just going to break this program apart. This is a drop and drag style program, so I'm just going to get rid of some of these here, and I'm going to keep this for now, and I'm going to drop this over here. Now what I'm going to do is I'm going to send out power through port 13, this port right here, and if I send power out through here, it will send out a 5-volt signal to this circuit that I've built in the breadboard. In order to do that, I'm going to use this here. This is an output. I'm going to set pin and then choose to high. In other words, I'm going to turn it on. And the pin that I want is pin 13. So I'm going to use the drop down here, and I'm going to go say set pin 13 to high. And then I want it to stay on for a certain period of time, and I have to tell it how long I want it to stay on for. So I'm going to click this here, which you'll find under control, the wait symbol. I'm going to wait 1 second, and then what I want to do is simply turn this off. So I'm going to drag this here over again, and I'm going to say set pin 13 to low. I'm going to turn it off. And I'm going to wait and keep it off for 1 second. So using drop and drag symbols, I've created a program. All it's going to do is send out a signal out of pin 13, and it's going to hold it high for 1 second, and then it's going to set that pin back to low or 0 volts for 1 second. Now, I can see if this is going to work properly by going up here and going to start simulation. So if I click on this, we can take a look at our circuit here. We can actually see that yes, the LED is flashing off and on. So we built our circuit correctly using the hardware properly. We've programmed our Arduino to turn on the LED and flash it off and on every second. Now, it's a little bit hard to see, but if you zoom in here, you're also going to see an LED on the Arduino that's flashing at the same time. The reason that I picked port 13 is it actually is driving this same device here, which is another LED. So they are flashing at the same time. This is what you call the built-in LED on the Arduino board. It is useful for different things. So anytime you want to use an output, like sending a signal to an LED, you could use pin 13, and then you can always see if it's working on the built-in LED as well. Now, last thing is, this is a drop and drag style code, but we are going to be programming using a language that looks very similar to C. And what Tinkercad will do is, if I go to code, and if I stop the simulation first, I can actually go to the drop-down menu and I can convert the block style program to text. So when I do that, it says, do you want to close the block editor? Once it converts to text, it's going to stay in text, and you're going to lose any blocks that you've built. So we're going to say yes, we want to do that, so continue. And there we have our program and what it looks like in something very similar to C language. The way it works is we have a setup area, and in that setup area we are telling the Arduino board what pins we want to use and for what function. We're telling it that we want to use pin 13 and set it as an output port. That is what we're doing in void setup, setting up any pins. Inside the void loop, and notice these brackets here, this is our program. We are telling the Arduino board that in the first line I want you to write, in other words, send a high signal to pin 13, and then delay for 1000, that's 1000 milliseconds. Then the next line we're going to tell it to write to port 13 again, but do so with a low signal, and then delay and hold it for 1 second. Now the way microcontrollers work is this loop inside here is an infinite loop. It will continue to flash the LED circuit off and on forever. So there, we've built a very simple circuit. We've used a block program to turn off and on the LED. We've converted it to the language that we are going to program in. and there, you built your first circuit and you've done your first program. That's it for this tutorial. You are going to build something similar to this and do a screen capture and hand it in as an assignment. That's it for this tutorial. Take care. We'll talk to you soon.